Hey everybody. So this is the third video in the series of using XAML on pyRevit, IronPython inside Revit to be able to create, amazing graphic user interfaces to interact with the user, and it's sort of like in the most efficient and user-friendly way to get the information that you want from the user, to be able to deliver the information that you like to deliver to the user in a sort of like in the best way you can, instead of just printing out text to the output window. So this is the third video in that series. In this video, which is hopefully going to be a shorter video than the other ones, I really want to focus on a couple of sort of like core subjects that is absolutely important to understand when you are working with any application that requires input from the user or needs to provide output to the user. Let's call that I/O, input and output, between the sort of like the process that's running and the user that is going to be using this process. There are a couple of things that we want to touch today in this video. One is the single-threadedness of the sort of like the GUI user interfaces and the event system. And we'll talk about a little bit more about these events and the user action events and stuff like that. And then we'll talk about data vs representation of the data in the graphical user interface. I'll make another videos to discuss the reactive data binding between the data, and I'll explain what reactive data is or reactivity is, which is sort of like a newer term when it comes to graphical user interfaces. You hear that a lot when working with web frameworks and whatnot. And we'll also talk about running sort of like mathematics intensive or process intensive tasks on separate threads, so you don't clog your user interface. But the stuff that we're going to talk about, these three things that we're going to talk about today, are absolutely important in really understanding how sort of like an operating system and a process talks to the user and shows these user interfaces and gets the info, and it can show the info to the user and whatnot. So I've drawn a very simple graph here. We'll grow this graph as we talk in this video about these different subjects. But basically, imagine we are sitting on a very simple system with just two CPUs on it. Now, this could be one single CPU that is hyper-threaded to provide two CPUs, two logical CPUs to the operating system. It could be two actual CPUs. The details don't matter. The CPU for us is a single thread of execution. So when the CPU is running any task on it, it cannot run anything else. So that would be a single thread of execution, right? So this CPU is running our program, let's say, and imagine that because our program is running in a sort of like a managed environment by the operating system, imagine that operating system is also using the CPU number one for its own resources and stuff like that. For the first example, we're going to talk about two main examples in this video. The first example would be using an application, a piece of software that is sort of like providing the output to the user or getting the input from the user through a terminal interface. So that terminal interface would be something like this. The command prompt in the Windows or PowerShell or Bash or Fish or other sort of like console applications that is sitting within a sort of like a terminal application that looks kind of like this on Mac OS. It looks slightly different on the different distribution of Linux that you're running, or it looks different on Windows as well. But the general sort of like workflow is that you type the command name, which is going to be your application name. We call it command because sort of like we are in a terminal environment. Generally, we call it command. But let's say I want to get the version of the Git application that I have on this machine. I provide the name of the application. I'm basically telling the console, this Fish console that I'm running, or Bash console, or PowerShell, anything else that you're using, doesn't really matter. The sort of like the specifics of it might be slightly different between different operating systems, but the general approach to this is almost identical. You provide the application name. I'm telling this console application that this is the application that I want to run. And this console application would run my application as a child process to itself because it wants to manage that. And then we pass a series of options to this command to sort of like get to this application to get it to do something for us, depending on what options are available for it. Generally, you can just say, by the convention of most of the CLI tools, which is going to be the command line interface tools, CLI, you can provide some options to get a help and see what commands are available and stuff like that. But let's say for the sake of this video, I want to say git version, and I want to get the version of the Git application that I have installed on this machine. And it tells me that's the sort of like the Git version. And this is actually the application getting its own version and printing it on the output window, providing that information to me. So it's providing the output to me as the sort of like the user. And that's a pretty simple interface. Now, depending on the complexity of terminal applications, you might be able to do, sort of like more complex terminal applications that might look like this. Actually, I don't have Docker running. Let's actually not use that as an example. Let's use HTOP. You might have an application that looks like this, sort of like, taking the whole process and whatnot, or something like this that we have seen before in like old schools when we in the old operating systems, you would see an interface, text-based interface like this. So for the first example, I want to show you an example of an application that's designed to work with a terminal. It would be a CLI application, command line interface. It won't have any windows or anything like that. It's designed to sort of like communicate with the user through the terminal window. So in that case, if we assume, as the example, sort of like we set the example, the CPU number one is running the operating system, the CPU number two is running the program, sort of like managed by the operating system. The operating system puts the this program that we're running on the second CPU. I'm not going to get into too much detail about like how this console application is actually running our program. Let's say sort of like our program has started to execute, and I'm going to draw a line as sort of like the line of execution. Let's say this is going through the history from left to right of the screen. We start the program. We ask the operating system, let's say through a function or command, to input, show the user, enter name, and sort of like wait for the output. And then let's say we want to put this into a variable like that, right? So at this point in time, we sort of like we use the operating system to use the operating system services to ask the user through this terminal interface, show you the prompt and ask for a name. Now at this point, the user interface will show a enter name here. Enter name here inside the sort of like the terminal application, and you're supposed to type in the name right after that. Now, what is critical to understand here is that because our application is using the input-output interface of the operating system at this time, I'm going to just put it on the operating system side to just show that this function sort of like, it's halfway between our application and the operating system. Our application's execution is just going to wait here. The operating system is going to switch to running all the other applications and switch to different CPUs and make sure everything is running smoothly on the other applications that are running on the system. But the application that we are running, this program that we are running, is just waiting. If you let this computer live for the next 100 years, this application is going to remain at this sort of like at this point in its execution, waiting for an input. As long as the operating system obviously is not restarted and stuff like that. As long as it's the same machine and same session, that's the application that's what's gonna happen to the application. It's just gonna sit here. Let me actually I don't even want to write a let me refresh. Let's see if I have. I don't even want to write, sort of like show an icon like this, because this means that the application is inside a loop and it's sort of like continuously going through a loop waiting for the user input. It's actually not doing that. It's waiting for an input event from the operating system, sort of like coming from the I/O interface of the terminal. I don't really want to get into too much detail about this. The details of it, you kind of have to work with different programming languages to kind of understand how this is exactly happening. The point that I'm trying to make is that at this point, the application is not really doing anything. It's just waiting there for the sort of like in sleep mode, waiting for the operating system to wake it up and tell it that, oh, the user has provided some input, and you can go ahead and process that input in the way you want. So the user goes in and says, my name is Ehsan, and then hits enter. and that would be a sort of like a notification to the terminal that I'm done with the input. It would wake the application up, provide that input to it, and sort of like the application now resumes the process of whatever that is intended to do with that kind of input. Right? So it's just, it's going to go do whatever it needs to do. And then maybe at some point in time, it wants to sort of like, let's say, let's go throughout the time, later in time, and draw this time vector as well. Let's say that's sort of like the time. And then at some point in the future, the application that we have is going to request the operating system to sort of like say, hello, Hassan. And it's going to ask the operating system to send this message or data or whatever that is to the user as part of the output. And then the operating system passes this to the output terminal, and the terminal will take that string and will show it to you. It's important to understand that this terminal is separate from our application. When I run an application like Nano here or Edgetop here, my application is actually running inside that console, inside that terminal. So there's a sort of like a hierarchy of different things happening at the same time. Your application doesn't take over all the resources. Everything is managed by the parent processes, and the ultimate parent process is sort of like the root, the sort of like a session manager of the operating system running at the root of the system. All other processes and applications within that environment are children of that main root process. So that's generally what I wanted to tell you about this. If you didn't listen to any part of this, the only takeaway is that when on a CLI application, when the application asks the operating system to ask the user for an input through the terminal, through the input sort of like stream of that application, the application at that point really doesn't do anything. Like it gets halted here. It really doesn't do anything. When the operating system has a sort of like input appropriate coming from the user or maybe from other stuff, for the user, it'll wake up the application, and the application can process its sort of like normal process. You can test this yourself. Like you can create an application that does this, and then launch the application in your sort of like here in your terminal, and then watch the CPU to see how much of the CPU is being used for that application, and you see there's really none. The application is not doing anything. So that's sort of like how this works. The graphical user interfaces follow the same kind of logic. They're a little bit more complex because of all the graphical components and the interactivity of all these components, buttons, lists, and all that kind of stuff, scroll bars and whatnot that the user can interact with. Here is pretty much, it's very simple. It's just text-based. You just provide some text, and then they can print some text to you. Now, if they want to show charts and graphics and whatnot, let's see if I can launch Docker here to show you this as an example. I'm going to let this run, and we'll show it to you. If the application wants to show charts and graphics and stuff like that, it still has to use the limitation of that text-based interface to be able to show you graphical information. There's no way that it can draw things on the interface. Everything is 100% text-based. Let's see if I'm waiting for the, yeah, okay, so I can launch it. Now, okay, so let's see if I want to look at the stats, and then it's showing some graphs and charts and stuff for me in this interface, but all of these are drawn using the sort of like standard symbols and whatnot of the Unicode interface, Unicode standard in a text-based environment. None of these are actual line drawings and whatnot. So the application is using the limitations of the sort of like the text-based interface, with Genius programming and whatnot to be able to show some graphics in it. Okay, I'm going to stop at this point. Again, take away the application, ask for the user, sits there, doesn't do anything. Let's get rid of these stuff and talk about our application. Sort of like the same application, but this time we want to be able to use a graphical user interface, right? So I think I have it, yeah. Let's grab it from here. And let's say my application wants to show this and asks for the username. Okay, so previously we would have a terminal application sitting here that would sort of like act as the graphical user interface. Although the content of that terminal application is very simple and limited to text-based only, it would still be a graphical application that shows in a graphical environment with windows and stuff like that, and it has, what is it, maximize buttons, and you can minimize it, and you can change the size of it, and all that kind of stuff. It's not the window to our application; it's its own application, but it can communicate with our application through the operating system services and whatnot, which is going to be I/O interfaces between these two applications. But in this example, when we are creating a GUI application, we want to create that window ourselves. So we kind of have to use the operating system services that we talked about in the previous videos about XAML, like that system.windows.form.window, that base class that operating system is providing to us as part of the .NET framework to be able to create the base window and add a couple of bunch of components on it and stuff like that. Now, we have talked about all of these steps before. The takeaway from here, from this conversation, specifically about GUI, is very similar to what we talked about with the CLI interfaces. The takeaway is this. When my application asks the operating system to show this window to the user, providing the, let me actually draw that code behind for that window that we had, whether it's in C# or Python or anything like that, and it asks the operating system to show the graphical representation of that model that we defined for the user. The part of the operating system that generally handles this is called the window manager. Its job is to manage all the windows that are coming from, let me actually push this to the back, other windows. Let's say these are all, I'm going to color them, to differentiate them from each other. Let's say I have a couple of windows in my environment. Its job is to manage these windows. So when I click as a user on this window, if it comes to the top, that is the window manager of the operating system doing that. The applications could get information about this stuff happening, and we get there how this process basically works. But what is happening is that this is the window manager of the operating systems that's managing all this stuff happening on the screen, changes by the user and whatnot. So the question is, what happens to our application at that time? This code behind this class, this data code that represents that window on the application side, on our application side that we created in Iron Python or in C# or anything like that. After saying, so if you remember, we would say window.show dialog, let's say, and we would launch that window that way with that command. I'm gonna make this slightly smaller, it's kind of too big. Let's say that is what we do here to kind of show that window. And we ask the operating system that our window is ready, show it to the user. And the operating system will do that. Well, it's generally like in discussion with this code behind and the window manager that this process happens. We don't get too much detail about it, but this is what we do to show that window. Now, what happens is that the process here, our program, will go through this code behind that's provided by the operating system frameworks, the .NET framework. Will go into a sort of like a loop that's called the event loop. It's not, looping all the time. It's not using the CPU resources. It's waiting for events to come from the operating system. Very similar to what happened with the CLI application. When you have a window open like this, if you don't touch that window or don't touch anything around it, that application is really not doing anything at that time. It's not using any CPU resources, unless inside your applications you have multiple threads and whatnot. But this thread of execution comes here, creates that instance of that code class or whatever that represents the window, starts the window, and then goes into wait mode, waiting for events to come from the operating system. An example of these events would be a user clicking on the button. Then the operating system says, well, the event came through, and this loop here will see that event and says, okay, now I can go and process whatever function that was associated with that button and run that process. So you get the idea. If the user let's see if I have maybe a hand icon here. I don't click. I don't. Anyway, let's say when the user clicks on this button, let me actually draw a box here over this button. Let's say that's our button here, and then the user clicks on this button, and then what happens is that the operating system sends an event to this event manager. I'm going to move this here to this event manager inside our program and says, oh, the user clicked on this button. And then because we have previously registered a function for that button, then our process at this time can say, okay, I'm going to go back and run the process for that button. Let's say this is the code piece that is supposed to sort of like, oops, let's get rid of this. Say this is the code piece that is supposed to run the function for that button. And then at that point, the process goes back in here, and our program will continue running whatever it's supposed to do, and then it'll go through the process. Now, the critical thing to understand here is that our application waited for the user input, anything, maybe maximizing window, minimizing window. It could be applications, sort of like events that are technically not related to our application. For example, the user could click on a window of a different application, it'll come forward, it'll sort of cover our window, and then you get a notification from the operating system that another window is covering part of your application. You have been deactivated. Maybe this is a game that's running in the background. Maybe our application is a game. It kind of needs to know if the user switched to a different window so you can pause the game here. So these are the stuff that is generally happening, these events coming from the operating system to our process, and then the process decides what to do with those events. There's a lot that could be discussed. Like we can talk for hours about how this process works. The general takeaways is that our program is running on a single thread. It creates that instance of data, asks the operating system to show that window. The operating system shows the window and then puts our application in sort of like a loop mode, and says, okay, I'll call you when something happened on the user interface side, on the Windows side. And then anything that happens, it sort of like sends an event into this loop, and then our application sees that new event coming in, and it would process that event. In this example, that would be a click of a button. Now, the question is, what if I go here, and then let's say I don't know, let's say I'm running this application on top of Revit. Let's say by clicking this button, we want to go around and find all the elements in the Revit model and delete those. That's a process-intensive sort of like task. So when I click on this button and I go inside this process and start basically running that and going through finding all the elements and whatnot, because our application is busy handling this event, it can't really do anything else here because it's sitting on a single thread. That's why when you click on this button, your user interface gets stuck, because whatever you do, whatever you clicks and other things that you do to this application, the operating system will send it to this list of events that's here. But our application is busy doing something else. It can't really go back and process what's happening. An example of a really good example of it would be, let me see, I should have progress bars here. Yeah, perfect. Okay. Let me grab a progress bar example. Let's say I have a progress bar here that is supposed to show the progress of deleting all these components on the Revit model, right? If you go through this process and update the information on that process, on that progress bar, let's say you're gonna say self progress bar dot state equals, I don't know, 60. Well, it's currently 60. Let's say you stepped forward, you deleted a whole bunch of other objects and say, set it to 70. Nothing is going to happen on your user interface side. It's not, that progress bar is not going to update. Why? Because this change to this data behind that progress bar needs to be sort of like applied using this event loop here. So this change will trigger that, oh, I need to update that progress bar. But then the event is going to come through this event manager, and the operating at the sort of like our process is still busy doing other stuff, deleting and whatnot. That's the primary reason that you do sort of like process intensive tasks like this. Your application will get stuck. Another example of this would be if you want to fetch some information from the internet or a web server and stuff like that, and that would be a sort of like a time-consuming process. Maybe you want to read a big file or something like that. Anything that's sort of like more than, I don't know, 100 milliseconds or whatever, you will feel that the application is sort of like giving you a little bit of a lag or gets completely stuck. You may want to minimize it and whatnot, and it doesn't really behave, anything like that. So you would feel like, oh, my application is stuck or the window is stuck. It's really not stuck. It's doing its job. It's just that to update that user interface, that loop that its job is to handle all those events, it's kind of stuck handling that previous event for the click of a button and whatnot. That's one of the most important takeaways from this. And then when that process is done, then our application will go and say, okay, so now I have the results. I'm going to maybe actually in this example, we use the, what is it? A hello world kind of thing. And it would show a hello world prompt. Hello Exxon, for example. It will show a prompt like this to the user that, yep, that's happened. And sort of like hello Hassan, and it will show the results. And then you would see a button here that says okay on that prompt window, and then our application goes into wait mode again after it shows that, because it's waiting for the user input. That clicking on the OK is a user input, so it sort of like goes to the wait loop again, waiting for that. Nothing happening on the application side until you click OK, and the application goes back, sort of like the window goes away, and then we go back to our process here, and then continue doing other stuff that we are supposed to do. Maybe continuing to do so, it would be just coming back here again. So the application, you click on the button, it shows the hello sign, you click OK, and it goes back to the original window and then keeps doing the same same thing over and over again. This is one of the things that is extremely critical to understand. These applications, the CLI applications, and then the GUI applications, interfaces like these, they feel, very different from each other. But the actual underlying architecture and how the way they're sort of like executed is very, very similar. It's just that you're using different pipelines to do things. Instead of talking to the window manager to sort of like manage the events and sends the click updates and resize updates and stuff like that, it's using the I/O stream, talking to the I/O interfaces of the operating system, trying to get some information and whatnot. This is pretty much how all applications in the environment work. In the previous example, let me actually get rid of all these stuff. Let's say you have a web server that's supposed to listen to some signals or like other applications that are coming from the internet. Let's say our application is a web server that is supposed to serve a web page or whatnot. What it does is that at some point it goes socket.listen, and it says listen to this socket from the internet. I'm not going to get into too much detail of what socket is and how they're created and whatnot, but that's basically a port, external port from the application. And then it'll ask the operating system that I want to listen to that socket, and it goes into wait mode. At some point, some web browser on somebody else's computer and whatnot will reach out to this operating system and sends a message, and the operating system passes it along to this application because it knows that that's the application that's listening to the socket. And then the application will go do its job, fetch the web page and whatnot, return it to the operating system, and then the sort of like the process, and the operating system passes it on to the web browser that's working. That's basically, it's very, in a simple way to explain, that's basically how all web servers work. So again, at the end of this conversation, all the most important takeaway is that your application, although it might look like that has a window and there's a logic on the sort of like the code behind side, and when you click on the button, the application goes doing its job and stuff like that, all of this is happening on the same thread. So if you have something that is a processing, as an intensive process, intensive task on your application side, and you click on a button and it goes doing that, your window is going to get stuck. It's going to be fine when the process is completed, that task is completed, and it goes back to that loop again. It's going to be fine, and your application is going to be sort of like active again. But during that time, your application feels stuck. That's generally not a really good user interface design, because it's sort of like it's kind of it doesn't really have a good user experience. So we talked about this single-threaded nature of the GUI interfaces. Now, nothing really stops you from creating more threads to do other tasks. As a perfect example, you could click on a button. Your application can start a completely new thread. Says, go fetch that information from that website. Let me know when you got that information, and I'll update the user interface. And during that time, the user interface, the GUI, the window is fully functional. All the, you can change the shape of the window. You can interact with the other components of that window. Obviously, that creates a whole, different level of challenge for you, because now your application can run multiple different things at the same time, and then you kind of have to manage that. So we'll talk about the challenges of those when we get to the worker threads here in the next videos. So we talk about this single-threaded nature of the GUIs, the event system, and that loop thing that we talked about, that the application sits and just waits for an event to come through. And then we talk about the user action events like clicks and resizing the window and maximizing, minimizing, maybe dragging something over your window, dragging something outside of your window, and all that kind of stuff. And then the last thing that I want to talk about is this data vs representation of the data. I'm going to keep using the same chart here. If we have a window here, and let's say I have a piece of data. Let me go and grab something that is better suited for this purpose. I don't know where that thing is. General text. Oh no, I think there's something wrong. Yeah. Okay, so let's say I have a piece of data here that's called employee. And the employee has a name, and the employee has a sort of like job, and the employee has a I don't know, maybe other stuff related to it. And in user, this is the piece of data that we have. So let's say we read that from an Excel file. We read that this, we have a type. In Python, you might have it like class employee object, and then you have the initializer for it. And then you have, you might pass the name of the employee and the job of the employee, and then you have self name and then self job. So this would be the data. This would be class the type of the data, and then we will instantiate it and say employee number one would be, sort of like Ehsan, and homeless with this job. I'm joking, I'm not homeless. I don't know, architect would be its job, and then you have another person with I don't know, computer programmer. And that would be employee number two or something like that. So these would be the pieces of data that we have. Now, they don't really have anything that sort of like shows how they need to be represented on a user interface, because that user interface could be anything. It could be a terminal that we talked about it before. It could be a window, a GUI user interface. It could be a web page. It could be anything. It could be different frameworks that are designed to create different user interfaces. So the way you create a user interface for this piece of data is really dependent on what framework we're using. In this series, we're using the XAML sort of like and the WPF framework to create these. So let's say we have that window, and then we throw in a text in there. We attach that to the employee, say employee info on our window. Window on our window, and then we said sort of like, let's show the name here, and let's show the job here. So this is the data behind that information. That's the representation of that information here. This is the representation on the user interface. In the next videos, we'll talk about the challenges of changing this data and keeping the representation of that data updated here. It's not always, as we talked about, like with progress bar. Let's say if I have a progress bar here. So this is the progress bar that we talked about in the previous example. The progress bar is a representation of progress. The data for it would be a value between 0 and 1, let's say, right? So if we say self progress bar state equals, I don't know, let's say 0.6, means that our progress is supposed to be at 60%. But if you go and change this data on your, inside your progress, it doesn't always mean that that piece of graphical information is going to be updated on the user interface, specifically when we're talking about when we're using XAML and WPF frameworks and stuff. There's a mechanism that sort of like you have to create to notify this event management system that is running our window and is waiting for update messages and all that kind of stuff. to let it to notify it that, oh, you know what, the data that's behind that component has changed. You might want to go and change and update that component again. So if I go and change the name of this employee, you don't really see that name changing here. You kind of have to go and say, okay, so let's go and change, let's notify the window that that information behind that component has changed, and it would go and update that user interface here. Same thing here, if that changes, you kind of have to go and let the window know that this is what's going to happen. So always remember that the data that you have here on the data side is different from its representation. Um, and that's a critical, that's a very important piece. That's primarily why when you go in a sort of like a process, in intensive task loop, and you keep updating your progress bar, the progress bar doesn't really update in the user interface, because we are sending these events, or we are sending these events to the user interface. The user interface kind of that loop is kind of stuck doing the intensive process, and it doesn't have the time to update that that progress bar. So you would see, you would click on the button, your progress at 0, your application goes and does 100% of its job, and then when it comes back, you see the progress bar goes to 100%, and it wouldn't show any of the intermediate updates that you had done throughout the process. So but always remember that the data that you provide is sort of like different from the representation. And there are mechanisms that you sort of define this in a way that ties it to this interface, maybe in a one-way or a two-way fashion. Maybe there is information here that, like a text box here, that I can provide the name of that employee, and I want to say like my name, and then you expect that data to be updated with whatever that information that was provided through the user interface. So that's sort of like the stuff that we're going to talk about. The traditional method to do this would be, let's say, in the old sort of like ways of GUI programming, like the old Microsoft Foundation classes, the MFC sort of like Windows and whatnot. It would be that you would have a text box here. Let's say this is a box. I'm going to add a line around it. Let's say this is a box. And then this box would have an event that would say text changed. And then you would have a listener, a function inside your code that would say, whenever the text change, run this. And then this would be sort of like reading that value from it and updating the data. So it would say self name equals self.textbox box.text. So you would sort of like manually create a function that would read the value that's inside that text box and apply it to the data that's supposed to be behind this. We can still do this. If you go around the pyRevit source code and the sort of like the examples on the tools and whatnot, you see a lot of these use cases. You can still do this with the WPF. For a lot of times, this might feel simpler and whatnot, but there's actually a better way to do this, to tie this data directly to that index, sort of like text box, so when it's updated, or the text block. So when the data is updated, that information is updated, or when the text box is updated, the information, the data behind that component is also updated. We'll talk about this in the next videos, and I'll show you a couple of sort of like functions and methods and classes that I have provided as part of the pyRevit interface that would make life a little bit easier for you working with WPF and sort of like creating reactive data binding and whatnot. I'm going to close this video at this point. Remember that we talked about the single-threadedness of the GUI, the event management system. Always remember, if you're taking one thing from this presentation, actually, if you're taking two things from the presentation, the first one would be that your application, your GUI, the window, and the logic behind it are part of the same thread. Never forget this, unless you architecture your application in a way that would be multi-threaded. That means that if you do something on the back end of your application, on the code side of the application that is intensive, your GUI will be stuck. There's no question about that. The second take would be if you sort of like, you can design your application and draw a line between where the data is and where the representation of the data is in the user interface. So you could have bi-directional communication between the two. When the data changes, the user interface updates automatically. You don't have to do these updates manually inside your code with events and stuff like that. especially when you have a lot of different components, it becomes a lot of work to create all these extra manual steps of updating information on the user interface. And the other way, whenever the component on the user interface gets changed by a user, the data behind it will also be updated automatically without really you creating all these listening events and stuff like that that are supposed to update the data. In the next videos, we'll talk about the reactive data binding and the worker threads, and I'll show you how to sort of like do this, do a proper implementation of this data and representation, and sort of like design it in a way that's fully automatic. And in the next sort of like in another video, we'll talk about how to create separate threads to do the work for us, the computational work, the intensive work on a separate thread. So our GUI is sort of like not stuck doing this. At this point, I'm going to end this video and I'm going to show you a final example here. I'm going to run this pyRevit telemetry server here, and I'm going to go to pyRevit, here to pyRevit, and I'm going to launch my pyRevit application. This is something that I recently implemented in pyRevit, and I just want to show you what this sort of like interactivity means between the user interface and the process that's running in the back end, the logic behind this window and how it gets stuck. Now, pay attention when I open this telemetry expander, there are a couple of boxes there that you can provide the telemetry server path to it. This settings window has a mechanism that can check whether the server in the back is active and alive and it's working or not. But because it needs to communicate with a sort of like server that's sitting on a different operating system at this in this example, the process of checking the whatever that's happening on that operating system, if the server is alive or not, could take a little bit of time. And if I click on this telemetry and would want to expand it, and the process of checking the status of that server is going to take 10 seconds, then my application would be stuck because it's waiting for that information to come back to be able to update the user interface and say, oh, yeah, you know what, that server is active. Because of this, I've designed this window in a way that launches that process in a separate thread. I'll show you this in the other video as the example. But let's see what happens when I click on this. See, it goes, its user interface is active, and then it quickly goes and checks the databases, and it updates these two orange boxes with that information, and my application is like fully active during that process. It doesn't get stuck, anything like that. The thread does its job, comes back whenever it's ready, and update the components on my user interface. This is one of those things that we talked about. And in the other video about the reactive data binding, we'll talk about an example like this, that I would have a piece of data that is tied to this text box, and whenever I go and start changing that, the data behind the screen changes, and that triggers the updates to the other components that are sort of like using the same data to provide that information. So I can, type here. You can see all of that is being done automatically. If I show you the code behind, the code would be very simple. You don't have event managers listening to the changes in this text box and stuff like that, and updating all that kind of stuff. So we'll talk about these two sort of like examples in more detail in the upcoming videos. I'm done with the conversation about this video. Let me know if you have any comments, any questions. It's incredibly important to understand this again, and we'll talk about the reactive data binding and worker threads in other videos. Thank you.